Hello and welcome. So hopefully everything is working again. Twitch has been a little bit uncooperative today, so I do hope that everything is fine. Let's just double check quickly. Okay, that looks correct. And yep, that also looks correct. Okay, cool. So I need to kind of remind myself what the heck I was doing actually, because as usual I have completely forgotten stuff over the week. I have a bit of a to-do here from last week, but I kind of need to get into a habit of like writing down better notes at the end of each stream, because otherwise this is just getting embarrassing. There's one thing I know for sure that I need to fix, and that's actually our iterators. So I did a bit of research offline, and it turns out my current iterators are a little bit broken. So the problem is that all iterators, no matter what type, need to be default constructible, which was it default constructible? Okay, let's just double check again what were all the properties, because I was definitely missing some of them. CPP reference, iterator. So was it somewhere here? No, it isn't. The problem is it's not mentioned here, I don't think. Legacy iterate. Ah, okay, here it is. Okay, so it needs to be copy constructible. Copy constructible we do have. That's fine. Copy assignable, that's a thing I don't have. And the reason why I don't have it is because right now actually I have a cont. Well, not in this one. This one I just have a const member, which is already an issue. But the other... Oh, I did change it actually. Anyway, this is not copy assignable right now. So that needs to be fixed. Destructible is fine, and L values are swappable, which is fine, I think, in both cases. So this is the actual, like, unsigned needs to be swappable, which it is, which is okay. And here the bit set needs to be swappable, which... Okay, that's a fair point. That might not be true right now. I will need to double check that. So, okay, let's take notes. So, bit set needs to be swappable. Is it 2-piece? I don't know. Yes, 2-piece, yes. That's how you spell it. And... Oh, I need to... Sorry. I just realized I don't have the chat opened. So hopefully I didn't miss anything. Okay, now it is open. Right. So bit set needs to be swappable, and both the iterators need to be copy assignable. So set iterator and what was the other one called? Bit iterator? Yes, bit iterator need to be copy assignable, which means that I need to change things around a bit. And last time when I was writing the const expert tests, I was running into issues with these iterators, and I actually figured out what the problem was. So the thing is, when you have an expression that's involving a reference which not the bit set, but the which test was that actually? It wasn't this one. Do I actually have the set iteration test? Or did I just write the bit set? Oh, so this is bit set sets. Okay, so this one I think was failing, if I remember correctly. Because internally I did have... What was it? Oh shoot, I don't remember. Bit iterator... Bit set... Which one of these was failing, damn it? It was the bit iterator that was failing, right? Bit iterator. No, but this is bit set bits. Ah, yes, okay, here, right here, okay. So, right now, this one is taking it as a value, right? No, const reference. Oh yeah, but then the bit iterator itself is taking it as a value. So bit iterator, go to definition. Right, okay, so here we are. So previously what I did have here was a const reference, and then I was actually storing the reference over here. Now I'm just storing the value. The reason why this was failing with const expr was actually the fact that if you are taking a reference, it's still okay in the const expr context, but you need to make sure that basically one of two things is true. Either the thing you are getting in is a temporary, or if it's not a temporary, it needs to have a static duration, static lifetime. And of course in these tests it didn't, but it's a very easy fix in the test itself. You know, we can just make this static, and suddenly the A has static storage duration, and now I can take a reference of that. So that was a bit of a confusion that I wasn't like figuring out why it's not working, and that was the reason. Like I just, because this was a normal variable, not a static variable, because of that it doesn't have a essentially a constant address, right? Which is the core issue. If you are running a const expr algorithm, you kind of want to have the object to be in a constant place in memory, right? Which is of course not true if you have like a local variable, because then, you know, it depends on the current stack position. Right. So we can fix that. And that's the first thing I want to do. So first of all, this actually, I want to take a proper reference. Well, actually I cannot take even a reference, I can only take a pointer, because I need this to be copy assignable. And we'll see if that actually works. But it actually should. So here, well, it should actually be a constant pointer. No, but then it's not copy assignable again. Damn it. Okay, it needs to be a proper pointer. So let's just move these things around. And but what I think it can definitely be, so it can be pointer to a constant object, yes. So the pointer itself is not const, but like this, right? Hey, welcome to our stream. So yeah, I'm also working on variants. Right now the only variant that's working is diagonal Sudoku. But actually right now I mean is still finishing up a big refactoring that I started to actually support killer Sudoku, because I kind of realized that the way I structured my code wasn't really great for supporting killer Sudoku. But yeah, I mean the funny thing is, like, it turns out that many of the variants kind of don't need extra code really. Like, the moment you kind of support basic Sudoku, like, the variants kind of end up being just rehashing of the same algorithms. So that's good, but yeah. Okay, so we can't keep these const. These should all be fine. Okay, let's see what happens. And I think my connection to the server just died. What the heck? That's weird. Okay, oh no, not Sudoku algorithms. Which test was that? The const expert test, yeah, that one. Okay. No matching function to call, yes, indeed. Okay, so that was down here. Okay. So now this thing should also take a pointer, otherwise things would break. No, this should be fine. It just needs to be like that. Okay. Okay. Now we're running into const expert issues, I think. So let's see. Right, no, so this is inside of the test. Yeah, so okay, so here we need to take an address of this, but since this is now static, it should be actually okay. But we will see. Okay. I'm not sure why the other ones are complaining, but let's... Const expert unsigned count bits. Okay, this is a bit strange. Ah, right. Oh, this will be interesting because now I'm taking a pointer to an argument, and that I have no idea if it will actually work fine. Oh wow, it actually did. Okay. I'm genuinely surprised. Yeah, there's still something I don't quite understand when it comes to const expert and functions. Because like in a function context is like, it seems that the compiler is okay running way more things than if I just write like the code inline, which is a bit weird to me. Yeah, I don't know. But okay, so now since we have the pointer, I can actually make this copy assignable. So that will be const expert bit iterator this might not... Oh, I wonder if I can make this const expert. I'm actually not sure. But I guess we will see. And yeah, we can have the default one because we just have two fields that can be just assigned around without any issues. Because this pointer is a weak pointer, so we don't really care if it's valid or not. And this one can just become copy assignable without any issues, because there's nothing super special about this one. It just has one field that can be easily assigned without any issues. So let's just do that. Oh, and it should definitely be no accept and no discard. Yes. No accept and no discard. Over here as well. So no accept and no discard. Okay. Is it still working? It's still working. Okay, cool. So now we should be satisfying the copy assignable here. We still need to make bit set swappable. It actually might be, but let me just okay, I need to double check how std swap is actually defined. So std swap move constructive swappable. Yeah, I don't think we need to specialize this code. I think it will just straight up work. And considering our class is just basically a 64-bit integer at the end and an 8-bit integer next to it, there's no benefit in making anything custom here. We can just go with the default, and that's fine. Okay, so that's working as well. So cool. Our iterators now are fixed. So that's done. So I have the... Okay, let's just go through the tests, because this was the thing I was doing last time. So the test we have... Okay, let's just create done and to do over here. So const expr is done and it works. Okay, square test. I think this will all be broken because we removed square. But I wonder, like, can we actually... Okay, so for this one I think I just want to double check if in my const expr tests I'm actually testing my bit set enough. I think I am, because this is what we replaced the square with. So what is this testing? This is just testing the empty square, right? Oh, so this is like a very short test anyway. So I think we technically do have that, and we can just get rid of the square test. Because okay, yeah, so here I'm testing a single bit constructor, specific bit sets, all the operations. Yeah, okay. No, I think that's good enough. I can get rid of this one. So let's get rid of this and let's clean it up in the square over here. Square tests. Yep. Okay. So that was square tests, Sudoku algorithms. Okay, so this one I don't remember what it was actually checking. Oh, it was going for the... Right, the finned fish. Okay, I think we replicated all these tests in the unique block. So, okay, so is the unique block test still working? Let's first of all do that. No, there is some broken stuff. Okay. So, what did I break? Right, because now I need the pointer to the things I'm iterating over. Yep, that makes sense. Okay. Okay. I guess it would be just easier to find like all the uses of the constructor and go from there, but yeah, why would I do it in the reasonable way? Okay, which file is now broken? Oh, is this... Wait, what? Why am I compiling this file? I should not be... For unique block test, I shouldn't be compiling sudoku.cpp. That's okay, that wait, no, so this is... Not quite sure what's happening there. But this I can easily fix. Yes. Right. Okay, so let's see if now it will be happy. And it is. Okay. So the unique block test is also done. But the thing I wanted to double check was the Sudoku algorithms. Okay, so let's just go through it. Union squares test. Oh, where is this actually used? I don't even remember. Okay. Oh, it's used in the solve naked groups, right. Right. Okay. No, so this one I still need. That makes sense. Did I replicate it? I don't think I replicated it. Number positions. Right. Oh, so I didn't actually replicate. No, okay. I was just confused. So this, right, the Sudoku algorithms test is the new one actually. What was the previous one then? Oh, that was in the block checker. That one I already got rid of last time. Okay. No, it's just me being confused. Okay, so this is all good. So this should actually be running fine. Yeah, and it is. Okay. And this I can get rid because this was the broken test from last time. Yes, indeed. Okay. Okay, now I'm starting to remember again. So the Sudoku algorithms is also done. Right, so so the solver isn't, the Sudoku isn't unique block. Yeah, the unique block I already checked. So yeah, so the only two things I'm missing is the solver tests and Sudoku tests, right? Okay, let's go to the Sudoku tests, and this will fail all over the place, I expect. Yes, indeed. Because we still have plenty of stuff here that isn't translated into the new model. Right. Okay. So this was... Okay, so this is just a helper function that gets me the internal block mapping, so I can then work with that. Sure, that is an easy fix, so it will just be the unique block, which is the replacement. Block mapping, yeah, that should be fine. Oh, reset to empty. So we don't have reset to empty anymore. What we need to do is assign bit set empty with size as the parameter, which does the reset to empty. Okay, so we don't have a square anymore, we have a bit set. Block checker, we don't have block checkers anymore, we have unique block, right? Okay, so that's... Let's just try and see if that cleared up at least a little bit of the warnings and errors. This is because this is s.size, right? But these things seem to be happy now, except for this one. Oh yes, because unique block doesn't have attribute ln. That does sound like something that could be true, so no, but it does have ln. Oh, but it doesn't have this thing as a friend, that's the problem. Where was that? It was over here. So this, oops, what just happened? Okay, that was weird. Right, so this should be a friend of the unique block. It's a little bit annoying that, like, for catch I need to kind of do this weird, like, helper function wrappers. But what is this complaining about? Yeah, okay, I don't know what that is. Okay, oh, we have more reset to empty to fix, sure, that I can do. Where was that? Over here, right. Bit set empty, and sure, we have the 9 hard-coded here, but that's okay. Empty 9u. Sure, that works. Okay, and then I already had stuff for the killer. Okay, so this for now needs to go away. Up to... Okay, this is actually... This should go completely away. Okay, up to here, I guess. Right. Okay, is that... Ah, I have failing stuff. Okay. So, what's the problem? Line 308. Oh, is this just serialized, deserialized that's broken? I guess it is. Yeah, that's definitely possible that it's not working. So let's have a look. What does the serialize and deserialize actually do? Because that's a thing I haven't touched, I don't think, after I changed the code. Okay, so I'm just calling serialize on the bit sets. But really? Okay, that's a bit weird. Why would this be failing? I mean, this is behaving exactly as before, it's just writing down the value of the data that I'm storing in each square. I don't really see how this can be broken, so I kind of expect the problem is in the code that's actually calling it. I mean, okay, let's go to the test. So it's failing over here, so let's just add some info. Yeah, also why is this... Oh, I don't have an override. I don't have an override for an output operator over here, which could be very useful, so let's do that. Yeah, I kind of think like the only thing we want to do is just debug string, honestly. There isn't really a need to do anything more fancier, but yeah, let's do that. So friend ostream operator out, bit set, and yeah, of course, oops, this needs to be std. The same over here, and then I just need to implement it in my CPP somewhere over here. And yeah, as I said, this will just be as output b.debug string and then return s. Very simple. And now if I run the Sudoku test, now it should actually output what's the difference. Okay. Okay, this is very strange. So on one hand we have... What? So on one hand we have an empty square. Oh wait, no, this isn't even an empty... What? Okay, this is... Oh, we have a problem with the max not getting set correctly. Because basically what's happening, like from this output I already see that like I'm not looping over the possibilities at all. Otherwise there would be just a bunch of dots here. So basically this loop doesn't do anything, and considering the loop is over max, that means like I'm not setting the max somehow correctly in my, I guess in my deserialize? Oh, but that actually makes perfect sense, right, because my deserialize actually needs to have unsigned max over here, because otherwise the entire thing makes absolutely no sense, right? So max should be max. And yeah, okay, so this all is getting slightly more complicated now. Yeah, previously this was all kind of weirdly implicit, and now I made the maximum explicit, and it kind of broke some of the assumptions in the code, unfortunately. Oh, I cannot spell again. Unsigned, right. Okay, so now this should be fine, but now I need to go to the sudoku.cpp over here, and in the deserialize I actually need to give it max, and max I have that number somewhere for sure. So rows, columns, pos. Oh, so this pos is actually the number of possibilities. Yes. That should be fine. Now it should pass. I hope. Okay, I think now it's getting a bunch of other problems. And 6F and stuff like that. Okay. Which, sure, that is definitely possible. Okay, so here we start. So now we are failing over here. So line 148. Okay, so something is broken in solve chains. This basically means, yeah. Okay, yeah, that basically means there's something wrong. This one needs a bit of debugging. Okay, so then we have a similar problem in the... Yeah, this is all chains are broken over the place. But we still have something in the serialize and deserialize. There's a segmentation fault. How does that happen? Okay, let's go to 279, was it? 27. Oh, that's just the header, right? Okay, let's just do debug, and this should catch the crash. Wait, what? What the heck? Okay, this is very strange. Well, first of all, this should be going over blocks, not over bit sets. Oh no, because this is data is actually yes, okay, so this is a vector of bit sets. Okay, and data yeah, okay, no, this is good. But why would this fail? I mean, these are just vectors. Hmm. Is it that we don't have the data copy yet? That could be the case. Wait, where does... Yeah, because I don't think I actually check if I have the copy. Yeah, this is kind of assuming that the reset change actually... Okay. Basically, this is... I should first ensure that I do have the copy and then check stuff. Okay, let's see if it's still crashing after this. No, I think it's still... Oh, damn it, this is kind of... yeah, the Visual Studio Code sometimes really isn't amazing. Damn it, how do I... Okay. No, so this is still crashing. Is it still crashing in the same place? It is. But... Oh, this is weird. Okay, I need to kind of use a better tool to figure out what the heck is happening. So let's go to the build. Right. And just use valgrind to figure out what the heck is happening. Valgrind. This was Sudoku test that I'm running, I think it is, right? Yes. Oh, I don't have valgrind hit installed. Okay. Yep. Okay, so invalid read. Okay, I knew about that, but wait. Yeah, it's comparing against a null pointer, but I'm still not quite sure where the null pointer is coming from. Because it's failing over here, which would mean that the... like either the left side or the right side is null. But that's coming from the change blocks where... Okay, this is strange. So this is 0, 0. Yeah, so I mean data copy seems to be empty. But why would it be empty? Oops, no. Ah, keep closing stuff I don't want to close. So data copy is... Wait. Oh, am I... Oh, I think reset change is actually broken. Go to definition. Ah, yeah, because reset change isn't doing anything right now. Ugh, damn it. What reset change needs to do is needs to call make copy. Okay. Yeah, no, now things are starting to make sense. because make copy is actually the thing that initializes the arrays. Wait. Oh. What just happened? How did this break? This is 543. Did I somehow do undo? Okay, that's a bit strange, but perfect. Okay, so now it's not crashing anymore. Okay. So now we just have a bunch of failing tests, which... but this serials is still broken, which is strange indeed. That should not be happening. Yeah, this is weird. So Sudoku test line 3 to okay over here, right? How did it actually compile if I... That was a bit... Am I editing the correct file? Weird. Okay, so... What are we actually doing here? We're just doing serialize and... so this is actually testing the solve, and the solve currently is broken. So okay, so this makes perfect sense. Okay, cool. No, this is. Why did I actually try to do that? That's a. Oh, because I called the solve on both. Then. Yes, okay, so it passes through this test. Yes, okay, so it passes through the test that both of them end up with the same solution. It just fails on this one because yeah. Okay, now makes sense, everything makes sense now. Cool, so let's actually try to figure out what's broken in the chains algorithms now. Actually, let's double check other stuff as well. So, am I actually testing these methods? So it's such as the helpers. So this is checking for the mapping. Okay, I think I need to clean up this test a little bit because I don't think I'm actually testing this to Sudoku properly, because I should kind of test all the methods that I have over here. Oh, and I need to, right, I should also test these that I never really tested. Okay, I need to add bunch of the tests that I currently not having implemented. Okay, so let's do that. Hey, thanks for the follow. Okay. Yeah, somewhere over here. Why do people do that? Yeah. Okay. So test checkers. Oh, right. So these are the chain methods. Oh, am I actually still using this one? Yes. Oh, in the soft chains. Okay. Okay. Set solution. Check against solution. So I mean, okay, I'm testing the serials deserialized. That's fine. Has changed, reset change. Yeah, I need to add this for the bracket operator. Right. Changed blocks. Control blocks. Right. Okay, let's just do a simple test for the bracket operators. So, test case. Simple operations. So we want to start with, yeah, I guess we can, it doesn't really matter which, like, what is the starting state that much. We can start with this, for example. Okay. And yeah, let's just read it in. So, okay. Okay. So, test. Sure, let's do the first row. First element. Oh, why is it not doing code completion again? Damn it. This has been really annoying me for a while now. Right. Oh yeah, this is the method I'm looking for, singleton value. So the singleton value should be 4. Then, yeah, the same row, but the last column should be 3. So let's just test that. And let's just test one more row. Let's say this one. Basically just to exercise the code a bit. And sure, 7 that's fine. So singleton value is 8. It's just a very simple test for the accessors. Right, now I want to test for the has change, reset change, and changed blocks. It's actually the make copy. Oh, so yeah, okay, so these are private, right? That makes sense. Right, so these three methods now I want to test those. Oh, and I guess I should also test the size. Yes. So actually over here I can also test the size. So test.size should be 9 over here. I'm pretty sure I also tested elsewhere, but I mean, it doesn't hurt anything if I do this. Okay, so these three things. Change tracking. Right. So let's start with the same idea. Maybe I could just create a helper class for this, because most of these tests kind of just reuse the same stuff. Okay, I will see. Maybe. Right. So at the beginning, yeah, okay, so first things first. I think both the stream operator and the constructor should actually set up the data copy, because I think semantically it makes sense that after this constructor has changed will return false, and the same after the stream operator it should also return false, because we basically, like, you know, overridden the state of the puzzle. So kind of makes sense to say there was no change, because like we just manually reset the puzzle. So it makes sense to track from that point on. Okay. So let's do that. Let's have a look at my input stream operator. That should be somewhere over here. No? Ah yeah, here it is. Okay. Oh, wait a second, what? Why do I have... Oh, I should get rid of this. This is no longer needed. Okay. Oh, first of all, where is it actually used? References. Yeah, it's only set in the... yeah. It's only set in the input operator, and that's it. Okay. So what I want to do is s dot make copy. Why is this not code completing? Oh, because as this is, damn it, as is the stream, I want puzzle dot make copy. Yes. Yeah. Okay, so this will reset the state of the puzzle. The copy we... Oh, damn it. What am I trying to say? This will reset the data copy of the puzzle. Okay. Now makes sense. Then in the constructor... Okay, over... Oh yes, so these are all deleted, which is okay. So I guess I have only this one constructor. I do. Okay, go to definition, right. And yep, just make copy down here. And then in the test, I want to check require test has changed should be false. So require not this. And the same over here. Require not test dot has change. Right. Okay, let's just save this here for a bit and let's see if this is actually working. I mean, there will be still the other failing tests, but the thing I'm trying to... so much output. Man, I really don't like the way this is handling the output. Yeah, okay, so I think the things that are still failing are just in the... yeah, just in the chains. Okay. So on construction the has chain is working fine. So now I need to actually change something manually. So let's do that. So test, let's just change, for example, this square. So that would be test 8 0, and let's just override it with the bit set single bit set. Oh, come on, Visual Studio Code, don't be such an asshole to me. I really need to figure out how to make my remote desktop working, because this is really getting on my nerves. Where is it? So this is circle square set empty. Single bit, right here. This one. So it's the max value and then the number that should be set. Okay. So just single bit, the max should be 9u and the number that I want doesn't really matter, but let's make, well, there is already 3 in that. Let's make something that doesn't actually collide. So let's do a 1. Yeah, that should be fine. So 1u. Okay, so now has change should definitely trigger. So require test.has change. So yeah, we should definitely have a change recorded. And I guess the changed blocks should also return stuff now, right? So let's just do this. Test.change blocks. So the blocks that there should be definitely 3 of them. It should be the column, the row, and the 3x3 block. So require that blocks.size is 3. And I guess I could like check it more thoroughly, but this should be fine. And I guess I can make the test a little bit more like safe by actually doing something like this. So if I now change the second thing, right? Let's say I change this square in particular. So that would be 7 and 1. And let's just change it to whatever doesn't really matter in this case. Single bit. 9u. Sure, let's change it to 2. Whatever. It really doesn't matter. But the point is, now if I do this call again, So let's do it. Because these two actually share the 3x3 square, the number of blocks that has changed should actually be 5, because it's these two columns, these two rows, and then the square. So now require blocks.size should be 5. Okay. Well, let's try to run this. And let's see if this is the... Oh, we have a problem. So this didn't work. Why? Ah, because has change is broken. Okay. Wait a second, but... Oh. Damn it. Right. So... Well, okay, so if these two are different, then just a return true. And otherwise at the end I just return false. Yes, okay. And I'm still not quite sure what this keeps complaining about. But yeah. This is one of the weird issues that for whatever reason Visual Studio Code is like not happy with C++ 20 at all. I'm getting very confused. Right, okay, so now the change tracking is working, and we are back to the broken chains that are still not working. Okay, but that's cool. So we have the change tracking working fine. What were the other methods? So the construction works, so these are all the chains, we will get to that. Set solution, right, and check against solution. Am I actually using this anywhere? References. Oh, now even references are broken. God damn it. Oh, why is this being so annoying? Well, let's do it the brute force way. Where's the find in folder? Yes. Check against solution is not being used. Okay. But I mean, this is a very useful thing that I think I should definitely use. So I think I should also test it. Yes. Okay, so is this actually... Okay, so this is actually checking if the bit disappeared that represents the solution bit. Okay, no, this is cool. This will definitely be useful. So let's go back to the code and let's make a very simple test for this. Do I have a puzzle that's actually solved somewhere here? I probably don't. Yeah. It's annoying. Well, I can always just jump to... Where is it? Here. Right. Okay. So let's just re-input this puzzle into here. Or maybe do I actually have it bookmarked? Easy puzzle. Oh, I have bookmarked the localhost. Ah, damn it. But that's actually okay. I can just reuse the properties. Just copy the serialized puzzle. Oh, come on. Of course. Copy it. Like this. Okay. Okay. Yeah, the problem is this is not this puzzle, but oh well. So let's just set this up. Damn it, and I'm really tempted to just really thinking about creating like a small wrapper for this and to simplify the code a bit, but I don't think it's actually worth it. Okay, so 31005 400. And actually, let's just use how do you do raw string redraw? No, oh damn it. Right, okay. So I was doing it almost correctly. And let's go back to here. So 008 008, and this way I don't have to write the new lines and stuff like that. Okay, 001 7 0 0 0 9 0 0 5 6. Okay, 4 0 0 5 0 2 0 0 0. Zero, zero, 9 0 3 0 0 5 8 9 0 0 4 0 0 0. Yep, 2 6 0 0 0 0 0 9 0 0. Okay, and the last line is 0 0 5 2 0 0 1 8 0. Right? Yes, correct. And when I solve this, it will be this. So yeah, there's like no good way to do this. It's annoying. So std string solution will be just this. So 931 625 478 568 734 291 724 4 1 9 8 3 5 6 4 8 3 5 7 2 6 1 9 1 5 9 4 8 6 7 2 3 7 6 9 1 3 8 4 5 8 9 7 3 4 1 5 6 2 6 1 2 8 5 7 9 3 4 3 4 5 2 6 9 and 1 8 7. Right, okay. Hopefully I didn't make a mistake copying this around. So now I can play with this. So right, this is all fine. So I have read the puzzle. Now I need to do test set solution with the solution. Oh, but wait, does this... Oh, this one's a Sudoku puzzle. Right, okay, so I need to do another one. So Sudoku solution 9U. And then read it. Damn it. Stream.string set it to solution, and then stream read into solution. It should work. Set solution. I cannot call it solution. Let's call it solved. Okay, solved, right. Oh, and this one's a pointer, okay. Yeah, the fact that it wants a pointer is a little bit awkward. I wonder, should I make it... Yeah, maybe this interface needs to change. Maybe. I'm not quite sure. I will not change it now. I mean, it's kind of convenient that it's just a pointer, so you can just have a local variable and it works. But I wonder if the... Yeah, okay, this is a thing I will need to think about a bit offline. Let's just write it down. So I guess let's just call it things to think about. So Sudoku class, should it own the solution, or is the current pointer passing logic good enough? Yeah, I will need to think about it a little bit. And actually, looking at the time, it's a great time to take a short break, so I will be back in like 5 minutes. See you then. Okay, and I'm back. Still need to deal with this one small thing over here, but I will resume the coding in a minute. Okay, this should be good enough for now, and back to the coding. Yeah, sorry for that. Working, well, not really working yet, but kind of trying to figure out another project that I'm kind of right now starting to materialize. I kind of want to basically have like Saturday working on the Sudoku and Sundays working on the new project or something like that. But there are still things to figure out and things to kind of iron out. And yeah, it's not really want to talk about it in specific terms yet because it can still totally not happen. So we'll see. Okay, so I was working on the solution checking, right? So here we set the solution, so this should definitely be okay, right? So if I do require test.check against solution, that should be okay. But if I basically break the puzzle, let's say if I set the first number to like 7 and it's supposed to be 9, right? That will definitely break it, so let's do that. So test 0 0 set to bit, set single bit 9u 7u. Now the check against solution should definitely fail. Okay. Well, one thing that also should break it is if I change the specific bit that's represented in the solution. So let's just reset this one back to all the possibilities. So bit set what was the, oh yeah, Sudoku square is the method. And then just break it by removing a specific bit. Okay, so let's remove from this square here, remove the bit 6. So that would be row 0, 0, 1, 2, 3. Okay, so 0 and 3 minus equals 6. So removing the 6 as a possibility, and that should also report that the puzzle is broken. Check against solution. Right. So let's see if that's indeed the case. I didn't rename this thing. Right. Check against solution. Okay. Yep, it seems that it's passing. Yes, okay. So serious deserialize we are testing already, the bracket operators we are testing, has changed, reset change we are testing, change blocks we are testing. Right. First unset. I don't think I'm using first unset anymore. Yes, so this should go away. Okay, let's just get rid of the first unset. That was used for the very basic solver that was using backtracking. Okay, is set. I should definitely test is set, even though it's a very simple function. Method, I guess. I can kind of reuse this, so let's just grab this. Actually, let's just grab this entire thing. Or maybe... Yeah, that actually makes sense to put it into the basic operations. So, solution, stream, reset it to the solution. Then I can just reread it into test, that's fine. And then, since this is a solved puzzle, so then require test dot is set. And then if I just reset one of the squares, so if I go test, I don't know, 3, 4 for example, doesn't particularly matter. But okay, I can do it very, just like the minimal thing, I just add 1 bit to it. So 3, 4 would be, which one actually? This is a 3, 4, which is this one, so let's just add a 9 to it. So now it's not just 1 as a possibility, but it's also 9 in there. So now if I do require test is set, it should actually be false. Because not every square is actually set. Right. So that was the is set. Then I have a bunch of these solve things. And that's kind of it. Oh, has conflict. I should test. Am I actually using it? Yes, the smart solver is actually. Oh, it's just in the test. Interesting. Well, since I'm only using it in the test. Okay, then I will not touch it for now, but this will need a revisit. Okay, so I guess the only thing I'm not testing is, oops, didn't want to do that, are these blocks and get throw blocks, get call blocks. Yeah. They will definitely be tested implicitly because these are used across the tests. But I should also create explicit tests for these. But let's just go and fix all these failing tests now. Okay, so the solve chain test is failing. So let's go to that. Test checkers, prune from chain. So it's solve chain test A, right? Okay, so I think I will need to draw these again because these were like very specific scenarios. But I guess right, it's the problem is it isn't removing the 7 out of 3. 1 is this one, right? And yeah, that one is missing over here. It should be missing, I guess. So it would basically mean that there's definitely something broken in our solve chains. So let's actually see what's happening here. This is interesting because this shouldn't have changed, I don't think. I mean, the problem is there's a lot of things that could be wrong. Actually, I should. Yeah, this is a little bit inconvenient that these are actually methods on top of Sudoku. Like, in particular, the get chain actually. This should live almost elsewhere. I mean, I know why it's here because it kind of keeps accessing, like, going over the data of the puzzle. But I'm genuinely puzzled that this is broken because I don't think what could be the thing that broke it? I don't quite know. Could it be that this is wrong, but this shouldn't be... Should still be fine. I think I would just need to step through this because... And I guess draw it. Okay, so let's first just draw this situation. So this was just concerning 7s, right? Okay, so we are basically starting with a state where there are no 7s in the puzzle, and then we reintroduce a bunch of them. Okay, so let's just do that. I think for that... Yeah, okay, I guess I can use my solver. That's fine. This will be a little bit awkward, so I want to do this. So let's just remove the 7 from everywhere. I think it will be slightly hard. Well, okay, or should I just... It might be better if I just do this, okay. Instead of this, let's just put in the 7 into the places where I edit. So 0 1 0 8 then here here 2 goes at the 4, which is here. 3 is 0, 2, 3. 5 is 6, which is here. 0, 2, 7, 8. 1, 2, 3, 4, 5. Right. So okay, so this is the situation, and the chain should remove 3, 1, which is this one. Why did I not? I should have annotated this test better, because like now I have no idea why this is actually the case. Okay. So, oh jeez. I think I will need to actually find the source where I got this from, because otherwise I will not remember why this is actually the case. I think this was on Sudoku. Maybe chains, loops. Is there a chain of 7s? Is this the? Yeah. Okay. So this one actually looks. Yeah. Okay. This looks like the example. So let's actually. Can I link? Okay. Let's do this. So this one is the X chain first example. Okay. Right. So the reason why I'm removing this one is because, right, there is a strong link between these two 7s. There is, that's correct. And there is a weak link between these two 7s. Then a strong link between these two 7s, a weak link between these two 7s, and a strong link between these two 7s. So it's either this 7 exists or this 7 exists, and this particular 7 sees both of them, so it needs to be removed. Okay. So now the problem is the problem is that the problem can be in many places. But okay, let's just try to debug it a bit and see. Like, I kind of expected something obvious. Well, at least I'm kind of hoping that it's something obvious. Okay, so let's jump over the get chains. So now get chains. Strong links, weak links. Okay, so we did find a bunch of stuff. I'm not quite convinced about what I'm seeing here. Oh, because this is it's like a hash something, right? What is this? What does this actually return? Chains graph. Yeah, okay. So these are unordered multimaps, so then these crazy numbers kind of make sense. Okay. Where was I? Debug you. Right, okay. So I mean the graph... I mean the graph looks like it's alright. So then maybe, is it the DFS traverse that's broken? Maybe it is. I don't know. Let's step into it. Damn it. Come on. Go to definition and let's break Let's break where exactly? Right, this call is interesting. And I think that's actually it. So let's just continue to... What the heck just happened? Does it never gets called? That's... That would be interesting. Okay, so if I do continue... yeah, it never calls the callback. So maybe it's really the graph that's broken. Oh, okay. So then I'm kind of guessing I actually need like a specific test for the like building of the graph itself. I mean, that would make sense no matter what. So I guess let's... What the heck? My phone is weird sometimes. Okay, anyway. So can I test this in isolation? So this is really just building the chains graph. I mean, yes, I should be able to just test this in isolation just fine. I think the only problem is that right now this is probably just a private thing, so go to the declaration. Oh no, it's actually public. Okay, so let's just make a specific test for the get chains. Yeah, okay. Okay, let's go... over here. Okay, let's have a test with build chains. Okay, and I guess... I mean, this is not a bad example because it has a bunch of strong and weak links, so... But maybe I should like handcraft something simpler. Okay, let's go back to here. So how can I make this work? Yeah, so if I do something like this. Yeah, something like this. This is reasonably simple, but it has interesting interactions. Okay, yeah, let's just try to reconstruct this in the code. So we just need a test, not the expect, for this one. So just remove the ones from the puzzle, and then the places I wanted to reintroduce them is 1, 1, 1, 7, That's a 5, 1. Oh, I guess what I should do, I should also have like one over here that doesn't have a link with anything. And I guess if I put one over here, that's also out of links. Okay. Yeah, let's do that. So the first one actually was test 0. That's 0, 1, 2, 3, 4, right? Oh, then the second thing I added was test 3, 5, right? Okay, so 5, 1, then 5, 7, and 5, 8. Then test 7, 1, 7, 7, and the last one was 8, 8. And okay, how do I do this? Right, okay, let's just save this as an URL in the code so I can just easily open it and look at it without like needing to figure out this thing again. Oh, and this is just a leftover from the previous test. Right, so then this can go away. Okay, so now if I do auto chains test dot get chains, right? This is, oh, for what number? I want it for number 1. Okay. So the nodes should be basically all these elements, right? So that's 2, 4, 6, 8, 10. So this should be 10. So require chains node size is 10. And let's just quickly test it and see if that's actually the case. Yeah, I think this particular test is passing, yes. So now I actually want to figure out if the links are correct. So change. Oh, come on! Why suddenly it doesn't want to code complete again? This error type chains, perfect. Like 2 seconds ago. What the heck is wrong? Oh, just a minute ago everything was okay, now suddenly everything is broken again. I don't understand what's happening. Go to definition, right. So these are the nodes. Oh wait, what's actually the unsigned? Now I'm actually a bit confused. Oh, these are like the absolute positions of the... Okay, I need more comments. So, absolute position of the square inside of the puzzle. Right. And then these are just unsigned, right? So actually, in the test, so this is a position 4. So this one is 10. This one is 16. This one is 27, 32. This one is 46. This one 45, 7, that's 52. And 53. This one is 64. This one is 70. Yes. And this one is 80, right? Yes. Okay, so what I expect is that require. So the chains I want to see. Okay, let's go back to the picture. Oh, come on. So this one, which is the position 4, this one shouldn't have any chains at all. So it shouldn't be in weak links and it shouldn't be in strong links. The same for this one. So that's just an easy check, right? So require that chains dot weak links dot count of 4 is 0, and the same for strong links, and the same for the other one, which is on position 3-5, which is 32. Okay, so the same for that one. So 32, 32. Okay, so this should still be correct. And I think it still is correct. Yeah, the problem is orienting within this output is really not amazing. Right, so now the ones that actually have links. So this one should have a strong link with this one and weak links with these two. So what are the methods on the multimaps? I always forget. So if I go to CPP reference, multimap, and it's this one. So okay, if I do count, returns the number of elements matching specific key. Right. Which I think is what I actually want. Yes, okay. So require, so that was the number 10, right? So chains dot strong links for 10, it should have one chain. Other way around, dot count 10. Should be 1, and I said it should have weak links with these two ones, but strong link also implies a weak link, so it should have total 3 of weak links overall. So require chains dot weak links dot count for number 10 should be 3. Okay, let's see. No, there's one extra assertion that failed now. So, okay, I think we run into interesting. So it doesn't find a strong link for this. Actually, I should stop using require. I should start doing check, because that way it will actually continue after. Yeah, I don't know why I got into the habit of using require. Oh, interesting. So it seems the weaklings are still okay. No, wait. This it didn't recompile. Okay, so it's 0 for everything. What the heck? Did I miscalculate the... No, the position is correct. It's 9 times 1 plus 1 is 10. Okay, let's just do a sanity check. So check chains.nodes.count. Well, it's not count because it's a vector, right? That find 10 is not chains.end. That should work, right? Oh yeah, because this is a vector, it doesn't have a find. But there is... wait a second, isn't there S3 find? Yes, find... find begin and... sure, so... find... chains... nodes... Wait, is there maybe an overload where it doesn't take iterators? No. Ah, that's annoying. I wish there was an overload where I can just give it a container and it would just work, but I guess I need to be explicit about what I want. Chains.nodes. And 10 is not chains.end. Oh, but not that end. Nodes.end. Right. Okay, let's see. And I misspelled nodes. Okay, one more time. Okay, so it is actually in nodes. But it doesn't... Okay, so it's really the chain building that's somehow broken now. So, okay, what is the problem then? Interesting. I think I need to debug it then, because... Okay. Yeah, so we know that this is correct, like the nodes ends up being correct, so we can skip over that. So this one, we will go over each block. Yes, that makes sense. We will get the number positions of that number inside of the block. That's still fine. Okay, so sure, let's go in. So position is 16, and I expect, yeah, concept. Yeah, so that was the first. So that should have been the first row, which, I mean, the fact that it didn't trigger on either of the conditions makes sense. Now we should be looking at the second row, which should actually have 2 ones. So this should actually, like, this condition should actually trigger. And it did. Okay. So we have the first and second. So first and second. Okay, the problem is I don't have a great way. Okay, I actually want to figure out what this is. So if I do add expression this thing, so this is saying 11. Oh, there's something. I have a off by 1 somewhere. I'm getting the feeling, because this is 11 and 17, and I think they should be 10 and 16, right? Let's go back to the code. Back to the test. Yes, so this should be 10 and 16, not 11 and 17. And I think I already know where's the problem. Right, so this is expecting 0-based index, but bit set returns ordinals. So we start counting at 1. Okay, so what this actually should be is this minus 1, and the same here. Okay. Yeah, and suddenly stuff is making sense, and the same thing happens here because, yeah, again, bit sets are ordinal, so they start counting at 1. However, like, this is an array, so array obviously is indexed from 0. Okay, that actually could literally be the entire problem that I had with the chains not working. Let's see. No, I think it's, well, it's, oh yeah, it did fix all the chains. There's still this test that's failing, but all the chains are now working. Okay. So let's just clean up the tests a little bit, and I guess let's finish this one so it's actually a proper test. So we did check this one. Let's just check also this one. Right, so this one should have a strong link against this and against this, and that's it. So let's do check, find the 80 in there, and if I do look at the number of strong links, the number of strong links should be 2, and it doesn't have any extra weak links, so the number of weak links should also be 2, because again the strong links imply the weak links. Okay, let's just rerun this, and we should still be, oh my god, this output is so annoying. Yes, okay, stuff is working. Okay, so let's just, I just want to quickly have a look at the rest of this file, just to make sure that these tests kind of make sense. Yeah, I mean, the thing is, this is actually worrying me, because this is kind of telling me that I did kind of break the solver, because if I just do solve, which would just run through all the solving techniques, right? Then it doesn't really solve anything on this puzzle. Which is, yeah, I don't know why that would be the case. Yeah, so now everything is passing once I remove this test. Okay, so this I will need to revisit. I think there's still something broken in there, but I will need to figure out what the heck is happening. Okay. Yeah, okay. So we definitely have an issue here. Because this test in particular, what it's actually doing is just literally testing if the solver is solving stuff. And I have two pretty simple test cases here. And I made both of them fail, so... and they fail on the solve, like it's not being able to solve this. And this should be pretty simple puzzles, so... Okay, so there's definitely still something broken. Still something broken somewhere. So actually, okay, I think that was actually a mistake. I don't want to reset change. Okay, so this didn't really help. Well, not that I'm super surprised. Okay. So... it's interesting, like like from the output from the other test, it did kind of look like nothing was really happening. So again, I would suspect that because I changed the interfaces, there's really just like something very straightforward that broke. But I'm not quite sure what. Okay, let's just... I mean, it still could be that one of the techniques is like broken somehow, and I didn't catch it in my tests, because... am I actually testing all... okay. Let's go through this again. So I'm definitely testing the chains. That's okay. Let's change, reset change. Yeah, I'm definitely testing these methods, but wait a second, where did like the solve intersection thing go? Is it in here? Oh yeah, it's in here. Okay. So yeah, I'm not quite sure what would be the problem. I mean, okay, let's just do a check and damn it. How do I do this? The thing is, I kind of want to see what actually happened, which means I kind of need to step over this thing, but that ends the... is it still running? Okay. So, are all the stats actually empty? They look empty. So this really looks like basically nothing happens. So, okay, let's try again. So I just invoke solve and then step into it. Sure, come on. Get me to the interesting stuff. Ah, jeez. Okay, I will need to do it manually. Go to definition. Oh, come on. Right, here. Okay. Let's debug it again. Okay, stop, everything. This goes away, and let's just debug again. Okay, so let's... Well, there's my problem. Okay, I don't know if you caught that, but basically what's happening... let's stop this. On the first pass in... Oh, come on, where the heck is it? This thing returns an empty set of blocks. Which actually makes perfect sense, because that's literally what I just did when I was checking, like, cleaning up this code. Oh man, this is annoying. Yeah, I mean, so this check is here to basically like bail out of this function if literally nothing happens in like a single pass. Like if there is no progress to be made, this is what this check is actually doing and trying to detect, right? So how do I make this work? Like, the problem is, and I literally just changed that. So it's actually not in the change blocks. It's in the, or is it? Oh, Visual Studio, why are you being so annoying today? Yeah, so the problem is, during the initialization, the data copy ends up being reset. So I still think it's correct for the constructor to set it up, but maybe I shouldn't be doing that on the input operator. So then operator, this one, down here I'm doing make copy, so maybe that's wrong. Maybe that's not the thing I should be doing. So let's see. Ah, progress actually. So we do actually have one test case that's now passing, but the second one actually has a conflict, which is interesting. That is indeed quite interesting. Where was I? I was here, right. So it's 40, so it's this one. So I'm actually somehow breaking the puzzle, I guess. Okay, let me just quickly double check this against, well, first of all, let's just try to solve it using my previous version of the solver. So 2, 9, 5, 4, 7, 2, 5, 4, 6, 1, 6, 7, 8, 9, oops, 9, 3, 4, 7, oops, 7, 5, 3, 9, 6, 7, 2. Okay. Okay, so this does actually solve it fine. Let's just quickly check if I don't see any collisions. Because I don't think I'm actually like checking for collisions over here. Yeah, so far this looks correct. Okay. So test conflict, right. Can I do info test.debug string? Let's see what that will produce. Oh, damn it, I don't have a debug. I thought I did have a debug string. Wait, I have debug print? Debug. I do have the debug print. Why the heck? No, I want a debug string. Oh, this is so annoying. Right. The same idea, but just create a string instead. And the easiest way to do that will be with a string stream. And then just at the end return s.str. Come on. And I should have... No, I don't have the include for that. Right, okay, so I need to do include s-stream over here. And that should be good enough. So let's see what's happening. Ugh, that's annoying. But I guess we can... Okay, that's like completely wrong. What the heck? No, it's not completely wrong. Well, it's mostly completely wrong. What the heck is happening? Oh, damn it. The problem is, it's kind of hard to figure out what's actually breaking. I mean... Okay, one thing I could definitely do is basically in the smart solver, somewhere over here, if and yes, code completion will not work, of course. So I could basically check against the solution over here, and if I basically, you know, if there's something wrong, just like bail out on the first error, which was, I guess I should do bool has solution return, oh come on, return solution is not null pointer. So then in the solver I can do if I have a solution, then if not, then just return false. Right. So basically bail out on the first problem. Now I should basically get to a better understanding where this is actually happening. Maybe. How is this crashing? Am I not initializing this correctly in the constructor? Probably not. Oh man, this class is a mess, I'm realizing. It has so many issues. I will definitely need to do a pass over this one and kind of clean it up, because there's so many like tiny issues all over the place. Right, I'm not initializing the solution over here. So, where the heck is it? Come on. So it is size solution puzzle type, right? So size solution puzzle type. So over here, solution, initialize it to null pointer. So now it should not be crashing anymore, because solution should actually be initialized, right? But it's not doing the checking because I'm not setting the solution in the test, right? So over here I want to do test.set solution, and okay, for that I also need all this complexity. Right, so solution will be this puzzle. So it's 3 to 1, no, 3 to 7, 189, 654, 684, 573, 219, 219, 951, 426, 873, 873, 136, 847, 592, 748, 295, 136, 592, 361, 487, 413, oops, 952, 768, 275, 638, 941, 869, 714, 325. Right, so that's my solution. Then I just need to string.string set this thing, then Sudoku solved 9u, just read it, so stream solved, and then set solution solved. Right. So now we should bail out on the first error, and it's not happening for some reason. Alright, because it's actually failing here. Right, okay. No, shoot. Damn it. This is annoying. How do I make this work? Yeah, the problem is... this one fails. So annoying. Okay, I can do debug string here and then basically do check test dot check against solution, right? So this should be a false because the previous one bailed out. Okay. Right. So what's actually wrong? So 3 is still okay, 2, 7 is okay. This is wrong. Wait, this is also wrong. It's like plenty wrong things over here. How did it not catch it before that? What the heck? Yeah, like this entire... like 3... Well, okay, I guess only these two are wrong. That's problematic. So this really basically means I'm not testing one of my solving techniques enough, and it's kind of leaking through and breaking stuff. How do I narrow this down? Kind of think like the easiest thing would be just like do test check against solution everywhere, and basically when that happens I actually know when I bail out. So I guess sure, let's just do that. Like, I mean, I don't really have a better way to like detect this problem. Basically, before every hash change, I insert this, and then what I can do is probably some off by one error still somewhere, but it's really strange that my test didn't catch it. I mean, okay, technically one thing I'm not actually testing properly still is the faint fish, because that one was very inconvenient to test. So that could definitely be... Wait a second, what's this here? This doesn't... where did this come from? Yeah, okay, this should be... This should actually be elsewhere. What the heck? It should be here. things I find when I'm moving code around. Okay. So has changed. That's over here. Okay. Okay. Oh, and I guess XY chains, well, maybe. It could be that the XY chains are also broken right now. Although, yeah, I don't know, I'm not sure. Right, and basically what I can now do is well, not like that, like this. So basically add a debug breakpoint, which will literally catch which one of these actually is the one that triggers. And yeah, then I can basically look at the specific rule that's actually breaking the puzzle. I just hope it's something reasonably simple. I mean, one thing I will need to figure out finally is the stupid testing coverage, because I actually don't know, like, I'm not quite sure how well my code is actually tested, because the testing coverage, I just never managed to get it to work. And because of that, like, all my testing has always been pretty bad in this project. So that's one thing I will definitely need to somehow figure out. Okay, almost there. Okay. Okay, so now if I run in debug mode, what the heck? Oh, that wasn't helpful. So it happens when we are solving singles. But it's not the source of the problem, obviously. Like, the puzzle is already broken at this point. Damn it, this is annoying. I actually don't know. Okay, I can beef up my check against solution a little bit. So right now it's kind of only one way. It's checking if I removed the number that's in the solution, but I can also check the inverse, as in if a square is set to a wrong thing. So that was in the Sudoku check. Okay, no. Oh, do I have it in the header? Maybe I do. Yes, I do. Okay. Right, so if data I times size plus j has single term value, so if it is set, then if data I times size plus j but it still doesn't make sense. Yeah, there's something strange happening for sure. It's not the same as these things. Singleton value. Return false. Because I mean, how do we pass this and end up in this situation being false? Like that's yeah, I'm really not quite sure how do we get into the situation. Okay, does it still break onto the... Yeah, it still breaks into the same place. I mean, it could be that this is actually broken. I mean, that's always a possibility. But... Okay, right, I will take a short break and I will be right back after that. This is getting very interesting. I'm reasonably confused at this point because yeah, it's weird. Okay, anyway, see you in 5 minutes. Okay, I'm back. So let's just okay, let's first of all close these. So where do I yeah, Visual Studio Code is just so confused that it's refusing to do anything anymore. So this one is in the Sudoku algorithms, I think, right? Solve hidden groups, yes. So, and I think, I mean, I should have tests for this, right? I mean, not too many actually, which is I mean, okay, let's just create some simple tests for this, because I basically just have one test, and maybe, yeah, maybe there's some weirdness happening. Right. Let's call this test 2. Let's create a test 1. Yeah, not... Again, still not quite sure. I mean, again, I really don't suspect this to be the problem, but... Don't know. Okay, so let's just do a very simple thing. Right, so these are all initialized properly. Filters, pushback. So let's just do. Let's just remove. Actually, yeah, let's just do it very simply. So values, let's say 3 will be a single bit thing. So bit set single bit 9U 1U. Okay, so then if I just do solve for a size of 1, count set everywhere should be 8, except for this one, it should be 1, obviously. So the third one should have the isBit set 1, otherwise everyone else should not have it. And that should be good enough as a test. So let's quickly switch to, where is it? Sudoku algorithms tests, and just run it. Okay, this is still passing, so that's fine. So let's try to do the same idea for the hidden variant. Alright. Yeah, I just loop over all the stuff and just remove the 1 from everywhere except, well, okay, I can do it like this, remove it from everywhere and then just reintroduce it back to one of the squares. So then solve it for 1. So count set again should be 8 everywhere. except for the square 3, where it should be 1. And again, so 1 should be set in the 3rd square, and well, 4th square, I guess, is the correct thing to say. And then everything else shouldn't have the 1 set. Okay, let's just quickly see what happens here. Okay, so this is correct. I'm starting to suspect there's some shenanigans with how I set up the blocks, actually. Do I test that? I think I do have some rudimentary tests for this somewhere. Change tracking, checking solution, build chains, test checkers, right. Test get mapping. Right. So let's just see if things are set up correctly. So if I do have the get rows and get columns method somewhere, I think. I even have a blocks method now. Okay, so let's just grab this. Go back to the test. Right. Okay, so just iterating over the blocks. Basically, the order of the blocks should be, it should be rows, then columns, then the 3x3 blocks, right? So if I take the first I mean, or if I just go over all of them, so const auto reference block test 3 blocks, so I just loop over all the blocks, right? And basically what I can prepare over here is like the position of the square that basically I should see when I go over the blocks. Result. Right, so this thing needs to be filled. So first of all is the rows. So for unsigned 0 to 9, so the result, and then of course the content of the row. So result pushback. So this should be the index of the row, so I times 9 plus j. Then the columns are basically the same idea, but in the opposite direction. So this will be j I. And then the 3x3 blocks will be I go 3x3, so two small loops, and then inside of those two small loops there will be another two loops that just go over the actual elements. Right, so now result pushback, so this should be I times 3. Oh, wait. Damn it. Okay, slightly differently. X is, well, not 0 actually, so X will start at I times 3 and it will go until I plus 1 times 3. Okay. And J, alright, Y will be the same idea for J. Y less than J plus 1 times 3 Y plus plus. Right, so basically if I'm at the square that starts at 0, 0, right, so it's the corner one, this will basically go 0, 1, 2, then this one will also go 0, 1, 2. And then if I'm like in the middle one, which is 1, 1, that one will go from 3, 4, 5, 3, 4, 5 over here as well. Okay. So now I just do result dot push back X plus X times 9 plus Y. Yes, okay. Because again, still X is the row and Y is the column, so that still is the same. Okay. So here I want to go over the elements of the block. That method was get squares, right? Get squares. So block dot get squares. So on top pointer square, and then I need to figure out the position of the square. So do I have a helper function for that? Probably not. So this gives me the mapping. I don't think so. Let's have a quick look at the Sudoku. So do I have anywhere access to the actual date? Oh, actually I do that through the square brackets, don't I? Yes. Yes, okay, so that's fine. What I can do is basically, come on, where's the right, so what I can do is check square minus test3 0, 0, but an address of this equals result iterator. So, and we start with iterator at 0, and then basically for every square we just increase it. So like this. Okay, so this should actually pass. So this basically checks like all the blocks are set up correctly. At least I hope it does. So this is back in the Sudoku tests. And stuff is complaining. Okay, unable to deduce auto. Right, because this should be a colon instead of assignment. Obviously. Still complaining about stuff. Right. Because I'm using iterator down. Okay, let's just comment this out for a bit and I will come back to it. Okay. Right. Ah, right. So no, so this is all correct then. Where it's actually complaining is a different test. Yes, because I changed the semantics a little bit. This one. This one should have a change, yes. Oh, interesting. Line 81. Ah. I really need to stop using require and start using check. Okay. Okay, so now this is all passing, so it's probably not the block mapping actually. Which is a bit of a disappointment because that would be an easy fix. Damn it. Right. I guess I can do the same check again. But now with just the row blocks and then explicitly the column blocks, and this should end up being the same result. Get row blocks, and without resetting the iterator, same thing over here for the column blocks. So we should still be passing. Oh, right, because now it's a pointer. Yeah, okay, so this is still passing. So yeah, at this point I'm pretty confident that the basic stuff is working. Let's just double check the mappings. So okay. So the mappings should be 3, that's correct. Then the first well, yes, actually, for a basic Sudoku, obviously all of them should be free. So I think that's this test actually, right? Get mappings, just iterate over all the stuff. Okay, but if I look at the corner square, look at the corner square. So the mappings, it's a vector, 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 right? I think it is. Go to the finish. Right. Yeah, it's a vector, vector, vector. Okay. So for the corner square, I actually know exactly which blocks I should end up with. So I can verify that. So this should be the first row, and if I just iterate over the first row, so get squares, right? Or I guess like this. What I should be getting is I minus this thing. Let's just reset the iterator. So this should be, oh geez, check. Yeah, straight up the iterator, and then increase the iterator. Let's just double check if I didn't screw up anything. Yep, okay, that's correct. So then the second one, I need to reset the iterator. So the second one will be iterator times 9, because that's the first column. That's still correct. And then it will be the first square. Yeah, okay, so this one will be a little bit tricky to do. So this will be iterator modulo 3 times 9 plus iterator, no, the other way around, iterator divided by 3 times 9 plus iterator modulo 3. Is that correct? Yeah, so okay, so this basically ends up iterator divided by 3 plus iterator modulo 3. Yes. No, the iterator times 3. Yes, that's the correct way. Forgetting how to do division and multiplication. Right. This should still be correct. Let's see. So, brackets are wrong. Okay, did I get this formula wrong? So, okay, so it should be 0, 1, 2, then we jump to the next row, which is 9, 10, 11, then, yeah, okay, so this is, yeah, okay, no, so, I don't think, yeah, I think it needs to be like this. So I divide the iterator by 3, then multiply it by 9. Okay. No, it's still wrong. Or is it? No, now it works. Okay, cool. Oh geez. So the block mapping is for sure correct. So it's at least one thing. Well, not for sure, but like I'm reasonably confident that the block mapping is not wrong. So what could be breaking my puzzle? Damn it. Like the weirdest thing is that if we go back to the solver, right? Like it fails here just after doing this solve, which is just looking for singles. Which basically means that yeah, I still don't get, like, why does it get caught here? This really doesn't make sense to me. Like, what would be the situation where the, like, ultimately, when it arrives here, the puzzle is already kind of broken, because all the singles rules do is kind of, there already needs to be the bad situation where, like, a number is only available in so the hidden ones is like a number is only available in like one specific square, but that inherently already means something already removed the number from the square where it actually should be, right? Because how else do we end up in the situation that it would get put into the wrong square? And for the naked ones, it's even more obvious. It's like basically there's like a number set in the wrong square. So how the heck do I end up over here? I really don't get it. Very strange. Well, does it actually get broken? Oh, interesting. It actually never goes to higher dimension solving techniques. So it is somehow just the singles breaking the puzzle, but oh, this is very strange. Yeah, damn it, the problem is I still haven't figured out how to where is this actually triggered from? It's not from the Sudoku, it's the smart solver test, yes. So I still haven't figured out exactly how to actually how to actually like output stuff so that the check framework doesn't basically just swallow all the output, and not the check, the catch framework doesn't actually swallow all the output. I mean, one thing I guess I could do is basically repackage the solver. So right now there's a loop inside of the solver, right? This one. So I can have a solve, but I can also have a static bool single step. And the single step will be basically, oh come on, basically the inside of the loop. Yes, so right. So everywhere where I'm doing continue, I will just return true. Everywhere where I do break, I just return false. Oops. Okay, so now down here, well, node is set and single step of this, and yeah, that's actually it. Right. Oops. Slightly differently indeed. Okay. So now what I can do in the test itself is basically over here. Right. So while not test is solved, and single right, smart solver single step and I basically can take it step by step, you know, from the server. Test stats. Right, what I want to do is always just do warn debug string. Okay. So now a single step. Ah. Okay. What the heck? Oh, is it not so? What's the method then? Oh, is set not is solved. Yeah. Right, is set. So while it's not set, just keep looping and outputting stuff. Okay, there's something wrong. Damn it. Why does this immediately bail out? Did I scrub the single step somehow? Well, I must have. So, I mean, well, let's just go for it. So yeah, if I check it against the solution, it's wrong, just bail out, right? I get the change blocks. If nothing has changed, then I just bail out because I have nothing to do. Sure. Right. If I made a change, I return a true. Right, and that should be... Why is that suddenly not working? Okay, let... I'm getting the feeling that there's something weird going on. Wait, why is the... I don't want to call this solver. Ah. Okay. Smart server test. I'm not interested in this test in particular. I just want the second test. Okay, let's do it. Oops, not run. Come on. Debug. Oh, what? Okay, let's try again. Okay. Yeah, okay, so continue over here. Wait. Now it breaks the puzzle on the first step? How? What the heck? That wasn't happening before. Oh, I'm getting so confused now. What is going on? I'm getting the feeling I need more coffee or something. Oh, come on, where's the test? Not the test, this thing. Yeah, okay, so... I mean, one thing I can do is actually... Yeah, let's do that. I can actually look at the difference. So, okay, go here. And, yeah, basic... So this one is already billing out. So, let's take the puzzle. And I'm sorry, this will be super hard to see, but I don't... the problem is I don't really have a good way to do this. Right. So, where's this? It would almost be nice to have like a diff. How hard would it be to write, damn it? I'm not quite sure. Yeah, Visual Studio is not cooperating today. Okay. I mean... Yeah, I guess the only thing I can really do without like writing a lot of code is in here. I guess in here. Basically put the breakpoints over here, and basically if I hit it, then you know I catch the problem because I know the coordinates. Right, let's continue there and let's see. So okay, so it's 3 and 0. So this would be the 1 over here. So the singleton, okay. If I do an expression, so data I times size plus j singleton value is 3. Well, that's wrong. And let's just double sanity check. Yes, like the expected one is 1. And yeah, really sorry that I don't know how to increase the font over here, unfortunately. I wish I did. But yeah, basically somehow we end up with a 3 in this square. I mean, how the heck would that happen? So it's basically this square. So okay, so we remove... Let's just take a notepad. Where do I still have... Yeah, I have it open. So I mean, we eliminate a 2, 5 and 9 from the row, right? Then the column removes a... Well, the column should actually remove a 3, then how the heck do we end up with a 3 if we should be removing a 3? What the heck? Like the column should be removing a 4, a 3, a 9, and a 7. So 4, 3, 9, and a 7. So 4, 5, 2, 3, 7. So I mean, at this point, and I'm sure there's something that gets removed from the square as well. Yeah, there should be the 6 removed from the square. So we should be just left with an 1 and an 8 over here. But somehow we end up with a 3? How the heck is that possible? Okay, let's just go back to our tests and try to kind of reconstruct this. So I mean, so this would be solving naked groups, right? So let's just create another test over here. I'm very confused. I mean, there could also be a situation that I guess the one thing I'm not testing is like the negative variants of these rules. Okay, let's do that. So for the solve hidden groups, right? What the heck just happened? So let's just create like a inverse variant of this one. Okay, so solve hidden groups 1b, right? So if I put the 1 into one more space, right? Then this should remain at 9 and this should also remain at 9. And 4 and 3 should have the 1 set. Okay, so let's just double check if this is the case. So this was Sudoku algorithms test. Yeah, that's fine. What is going on? Oh jeez, I'm seriously confused. Like seriously confused at this point. Like I can always kind of micro step through the process and try to figure out what the heck is happening. But this is exceedingly strange. Okay. So we said that in this situation, if I go back to the debug, over here, right? So from the row, okay, so at position 1 we should have a 2. Oops, no, that's Okay, at position 0, 1, 2, 3, 4, 5, we should have a 9. At position 8, no, 7, we should have a 5. Okay, so after this goes through, then 0 should have 6 values, 1 should have 1 value, 2 should have 6 values, 3 should have 6 values, 4 should have 6 values, 5 should have 1 value, 6 should have 6 values, 7 should have 1 value, and then 8 should have 6 values. And then just quickly double check that everything is fine. So 1 should be set to what was the thing? 2. 5 should be set to 9, and 7 should be set to 5. And then just like sanity check that 0 doesn't have the 2, 0 doesn't have the... Okay, let's not check 0 because that one is like at the beginning. So let's check, for example, the 4. So it doesn't have the 9 and doesn't have the 5. Okay, so this should be perfectly correct. And it is. God damn it, how are all the tests passing and it's still wrong? Oh jeez. Okay, I think I will just need to like micro debug this and try to see like which of the techniques is actually changing the value. Okay, so I can do that by going over here. Right. So what I care about is add expression. So I want to see sudoku.data at 0, 1, 2, 3. Yeah, so this one was the broken one, right? Damn it. And yep, basically let's just do that. And let's see when it actually changes. Okay, weirdly enough, it's actually not changing yet, which is weird. Because I mean, if the moment we do solve naked groups for the row 0, no, there's something very wrong here. What the heck is happening? Squares, size. Like literally in the first loop. Yeah, in the first loop it should actually remove stuff from this square. Why didn't it? Is there something wrong with the changed blocks? Wait a second. Okay, let's just go through this. So this loops over all the squares, right? If the square has changed, then... Oh, but this is a set of things. Oh, because I don't want to have the squares, like the blocks there multiple times. So that kind of makes sense. Yes, okay, so then the order of looping across the blocks can be basically pretty random. Okay. So then what I actually want to see as well is the ID of the block, I guess. I can figure that out. So I can do block minus minus Sudoku dot blocks 0 and take take this. No, it's not blocks. What is it called? Damn it. Why is today so weird? Checks, not blocks, right? Checks. Okay, so this is block number 22, sure, okay. And I guess what I actually want to see is this divided by 9 is... Oh shoot, no. Well, modulo 9 will be like the... like this, right? So modulo 9 is like the type of the block, and then other expression, this divided by 9. No, divided by 9 is like the type of the block. So 0 would be rows, 1 would be columns, and 2 would be squares, and the modulo 9 is like the ordinal number of the blocks. Okay. Oh, 0, 1. Yeah, that's still not correct. 0, 0, finally. So solve hidden groups shouldn't do anything. Solve naked groups though should actually change this square, and it did. Changed it to 237, and if I look at calculator programmer, so 237, so it removed number 2 and number 5 as possibilities, and I guess also number 9 because it's not showing the padding, right? So this is 1, 2, 3, 4, 5, 6, 7, 8. Yes, so 9 is also gone. Okay, so this was correct. So now I basically want to fish for which operation actually breaks this. So the next change, I need to be very careful and just watch when this particular square actually changes. Okay. So it was hidden groups for column. No, sorry. for the square... What in the world? So the square completely screwed it up somehow? I mean, the square should be moving a 9, a 7, a 4, and a 6. But it removed way more stuff. And especially on the hidden groups? Yeah, so this is... Okay, this is really weird. So this basically means that when I run the hidden groups on this square, it basically figured out that the only position for this number is here. And the 4 is... that's 2, so that's number 3, yeah. So somehow number 3 got eliminated out of like all the other squares as well? How would that happen? You know what? I will just do this over here. Like, I really don't know what the hell is happening. Yeah, let's just stop this and rerun this. So, okay, this situation is already wrong somehow, and I don't even know what actually changed. Wait, this is not even showing what changed. What the heck? Okay, let's just do it like this. So we do one before and one after. Okay. So what did it actually screw up? Let's have a look. So 5 is still here, 2 is there, that's fine. 3 is still a possibility, 4 is still a possibility, 1 is fine, 7, 9, 6, 8. So the bottom row is okay. 1, 4, 9, 8, 3, 6, 5, 7, 2, that's all fine. 8, 6, 7, 2, 5. This ended up being a 6 somehow. Which is completely broken because there's a 6 already here. Okay. Well, how the heck can we end up in this situation? And the weirdest thing is, like, this is all just like the top part of the puzzle wasn't even touched. It's just all stuff happening down here. It's like the bottom 3 rows. So no columns, it's just rows and squares. So I mean, okay, let's just... I guess let's just go back to the solving techniques. So the algorithm tests over here. And I mean, I can just replicate like this. So it's like 3 rows and 3 squares. So it's just 6 different blocks. So it's very easy to replicate. And I mean, we will see what the heck happens. Like, why does this 6 end up over here? This is like, if I'm not able to replicate this in a test, I will just go mad, I guess. Because like, I don't know, this is turning out really weird. I don't know what exactly is wrong and where and why and what the hell is happening anymore. Okay, so... And I think it's the hidden groups that are screwing it up, not the naked groups. Or I guess we can actually... Can we actually see that, if it's actually the hidden groups? Let's go to the solver. So if I just put a breakpoint here and here. Okay. Don't care about that. Yeah, okay, it's the... No, wait, wrong thing. Go away. Yes, okay, so it's the hidden groups. So I specifically need tests for the hidden groups. Okay. At least I have that much information. Okay. So... Okay, so then I don't need to replicate this part. It's because this is fine. Hidden groups, where are you? Okay. Yeah, this would be something very, very silly that I would just like bash my head in for like missing. Okay, so I kind of want to just verify that the like bottom arrangement down here. Okay, I'll just rerun this thing again. Okay, so I have the input basically over here. So let's just go row by row, right? So oh, but I guess the problem is it's an interaction between the it's like somehow the hidden groups screw up because the naked groups like remove stuff. Ugh, damn it. But the problem is, like, how did this 6 survive in the first place? Oh. Yeah, because, I mean, looking at this row actually, oh damn it, do I have a... Is this another off by 1 problem? Because the number that should be there is actually a 5. And I put a 6 in there. Oh. Damn it, but how... This is just so annoying. Bit sad. Yeah, so the thing that's strange is that basically for this rule to trigger, okay, I guess this will actually be interesting to see. So ether is 32. Like, we somehow had to have the situation where... Did I close my calculator? I think I did. 32. Right, so this is what? 2, 4, 6, 7. Am I doing it correctly? 1, 2, 3, 4, 5, 6. 6, okay. So I'm trying to set a 6. And this one is 185, right? So 185 does indeed have a 6 in there. And count is 1, size is 1. I mean, this all looks correct. I'm so confused. I mean, one thing we could do is basically I could put a conditional breakpoint here. So I only want to break if Yeah, the problem is I actually cannot do... yeah, like... The problem is I cannot get back at the puzzle from here, so I cannot actually conditional the breakpoint on like identifying the correct square. No, damn it, how do I debug this? I basically... Yeah, the problem is like it's that what makes it hard is that I basically caught the point where it's actually changing. But at that point, it's not necessarily the source of the problem. Like it's just that's when the problem manifests. I mean, the thing I would do normally is just do debug logging, but the problem is because I'm using the stupid check framework, not check, catch framework, that one will basically like get rid of all the output. So I could basically handcraft like a small test program to like kind of trigger this manually, I guess. Okay, one thing I could do is basically over here. I could actually split this up. I mean, actually, to make it more deterministic, I could just like ignore the change blocks and just do it over all the blocks. Okay, let's just try to do that for a bit and try to kind of narrow down the variables. Yeah, this is like a this is definitely not a desirable thing to have in the code, but it might help me debug the problem. So yeah, basically now if I do like single step, it like allows me to figure out what's happening, because it will go through like all the naked groups and then the hidden groups. So I can basically see if after the naked groups are processed, if there is any like obvious problem in the puzzle. Okay, right. So wait, what the heck? No, okay, here, right. What the heck? Now it actually works? So is it really the change blocks that are broken? But I thought I'm testing that as well. Wait a second. Let's go to the test. Sudoku test, right? Okay, so let's just make a very simple test. So test case. Oh my god, if it's the change blocks, my head will just explode. I mean, it would make sense because that's literally like the only thing that could be broken, but... Jeez, okay. So, right, I have this. I have a puzzle that I have just initialized, so all the blocks should be changed, right? So now if I just do auto blocks is test3.changed blocks. Now basically check blocks dot size should be three blocks of 9, so that's 27. Okay, let's see. Not this test, the Sudoku test, right. What the heck? 26? How did I end up with 26? That's like the weirdest number. Oh my god. Okay. Well... So... How the heck do I test this? Well, this is obviously already wrong, but I also can do... Oh, jeez. Changed blocks, unique block. Like ending up with 26 is exceedingly strange. Okay, unique block. Can I get at the blocks somehow, somewhere? So it's the checks over here. Do I have... mean, I can easily go over the rows and columns at least. So, okay, let's do that. So, in here, so for, oh, come on. Go over test tree, get row blocks, and blocks.count should be 1. Check, and the same for call blocks. So let's just check that. What the heck? There's one column missing. What in the world? Oh wait, okay. Actually, that could happen. Yes, okay, so there is actually a column that has no changes. And it is the only... Okay, so it actually makes sense. Oh my god, okay. But... what the hell? So, what is the problem then? Why the hell does it work? Like the moment I split it, it started working, which makes no sense to me. Like, why would it start working? Okay, I think I need more coffee and stuff, and because my brain is completely fried, I really don't understand what's the problem over here. And I really need to figure out what's wrong, because... Okay, let me try one more thing. So... let's just comment this thing out for a bit. Up to here, I guess. And instead of change blocks, just do sudoku.blocks. Because this way I can actually narrow it down. So if it's indeed something weird with the change blocks. Now if I do the solver test, no, it's really the like sequence first hidden then naked groups that's causing this problem. Okay, and if I do it like this, I suspect it will still break, right? Yes. So it's really the sequencing between hidden groups and naked groups. Am I missing? Like this almost feels like I'm missing a check somewhere that's like preventing me to like trample over stuff. So here I do have I skip over squares that have singleton values, right? I mean, actually, I think this check actually should be more complicated because yes, so okay. This is very annoying. I'm not quite sure if this can actually happen, but basically we skip. Yeah, I think this is the problem. Okay. Yeah, so, and yeah, okay, so this is why it doesn't happen if it's ordered first the naked singles and then the hidden singles. So there's a special condition here. So we skip over the squares that have there are two ways to fix it. Like either I just get rid of this. And actually I should just do that, right? So there's a specific corner case where that's basically causing this problem. It's like if there is a square, yeah, now everything is fine. Okay, so if I have a square that has the specific number already set, right? Then what can happen, there can be another square still, if I haven't run the naked singles, right? There can definitely be like a square next to it that also has the number as a possibility. But then if I skip over the square that has it set, well then obviously I will just not count it in the count, and then I can have a situation where, oh damn it, but I need to skip over squares. Do I? I kind of want to keep this check, but I just need to make it more complicated, unfortunately, which is super annoying. Right, okay, so let's just do this. So if we run into a square that has a specific value, we will skip over it no matter what. But if the square, like its value, has an intersection with the current like set we are looking at, we actually want to completely bail out, because at that point that cannot be a hidden group at all. Like if let's go here, right? So let's just erase this. I don't need this anymore. Oh, this is... Okay, so, like, imagine this kind of scenario, like... Right? And let's say... And this was basically what was happening, right? So, if I start looking at this row and trying to find, like, hidden groups, right? For the 6, I would skip over this thing, and then... Oh, sorry. And then basically count, oh, there's like one square that has a 6. Because I skipped over this one. But because I skipped over this one, suddenly I will think that, oh, actually 6 can only be in this square. But clearly that's nonsense, because 6 is already here. So I actually want to skip over all the sets that kind of contain already like a number that's set in one of the squares, which is basically this condition. So I reset the count to 0, so this condition will not end up being true, and I break out, which breaks out of this loop, which then kind of implicitly breaks me out of this if and goes to the like next set. Yeah, and this should still work fine now. Okay. Oh jeez. Okay, this was a nightmarish bug. Oh. But I got it. I managed to find this. I'm really hoping I don't have like more of these kind of bugs in the code, because the problem is like these are like interaction between different things. Okay, let's try to think like what would be the test case for this. Okay, no, I can actually craft a test case for this. Okay, so let me just fix this test case that I kind of had like half finished. What is my phone doing? Like, it keeps triggering for Google Assistant for absolutely no reason. And then searching for really weird stuff because I'm saying weird things. The funniest thing is if I say, okay Google. Oh, it did actually wake up this time. Okay, never mind. But usually it doesn't. Okay. Yeah, okay, this I actually need to change into like a normal loop then. So this will be unsigned I 0 to... Okay, and this I need to move out, right. Okay, like this. So go until the column's size, and if the column isn't column, so 0, 1, 2, 3, 4, if I is not 4, then check this, else check blocks count b is 0. Okay, so that should fix that test. Okay, let's just quickly run it and see if it's working. No, b was not declared at this scope, right, because now it's cos I. Okay, cos I, run again. Okay, and the test I wanted to add was in the algorithms. So right, so the hidden group, okay. So there's a hidden one in square 3, but what I also want to do is values 4, just set it to bit set single bit 9u1u. Right. And now what should happen actually is that this remains with 9 possibilities. Right. So 3 is bit set 1, yes, 0 still remains with 1 unset, but more importantly 4 is still bit set. Right. That's Sudoku algorithms test. Okay, let's see. Okay, now it's working. Oh jeez. Okay. I think that's actually it then. For today. I wonder, so let's just not this terminal, where's the, oh, this one, right. If I just do I have the no, this is still not running, unfortunately. Okay. Yeah, that's a thing I wanted to fix tomorrow. There's still something wrong with our main, even though other things actually seem to be working already. So, okay, is there any broken tests still? Or are things actually already working? Yeah, okay, so I mean, I think all the tests are working now. Oh, there were some tests that I actually commented out, so let me just uncomment those again. It was in, one was in the solver. Yeah, okay. Let's see. Okay, that's fine now. Okay. Wait. Oh, I'm running the wrong thing. Oh. Okay. Oh. 89. Okay, let's see. Oh, I need to get rid of the tons of debug. Required test is set. Right. Okay, maybe there was a reason for this one to be commented out. Okay, what is actually happening here? Let's just put it into a solver and let's see if the solution is correct. Oh, I did have some solvers bookmarked somewhere. Yep, okay. So 3, then 8, 5, 6, 2, 5, 3197. Oh geez, this is really hard to... Okay, let me add the spaces. Okay, then nothing. 2 goes here, then 5 goes here. Then nothing. 7, 4. 1, nothing. 2, 5, 0. Nothing. 7, 3, 2. Okay. Oh. Okay. Oh, just need to read on the side, sorry. So the last thing I did was this 2, so then 1, 0, 6, 3, 0, 0, 9, 0, 0, 8, 1, 4, 9, 5, 8, 6. Okay. Oh wait, is this actually... Oops, no, that's not what I wanted to do. Right, okay. Solve. Oops. Oh, because I disabled a bunch of things. Oh, okay, come on, solve it. Okay, so let's just double check if this is actually the solution that I have here. And yeah, let's just add the spaces. Because if it is, then I probably still have some bug somewhere. Okay, let's see. So 9, 3, 4, 7, 6, 2, 1, that's fine. 6, 2, 5, 3, 1, 9, 7, okay. 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 Just to side. Yeah, okay, so there is something wrong here. Definitely. Okay. So this is a debugging thing for tomorrow for sure. Oh well. I mean, kind of weirdly enough, Oh, I do set solution, so why didn't it bail out? Okay, that's particularly strange. Oh, maybe it actually did. Yeah, okay, anyway, that's definitely something for tomorrow. I have been streaming for way too long already. So time to relax a little bit and also work on some other stuff. Well, anyway, thanks for watching, and I will be back tomorrow at the same time, 2:30 p.m. Central European time, and then hopefully, you know, continuing in the coming weeks as well. So, see you. Have a nice weekend.